Good morning, friends. Today we'll be discussing the advanced television systems. Till now, we have discussed the black and white television, color television, high definition television, and digital television. So, in the unit number 4, we'll be discussing the next part of this particular television systems, that is Internet Protocol television, that is IPTV and mobile TV. So let us try to understand what exactly meant by an IPTV is. IPTV is an television over internet, which consists of two parts especially. One is IP on audio and another is IP on the video. IP on audio consists of audio signal is converted to IP packets, which are known as an IP audio. So the audio signal is first converted to the electrical signal and further which is converted to the digital and converted into the packages. In transmitter section, it particularly consists of the audio signal digitization, where conversion of an analog signal into digital signal, then audio signal compression, because due to digitization, the bandwidth of the signal increases, and to reduce the same, the compression is very much necessary, the same way we used to do it in digital television. Then after the signal compression, the timestamp is applied to the digital signal and the IP addressing is done. After this all, these IP are converted into the packets, means audio is converted to electrical, is converted to digitized, and after compression, applying the stamp and address, it is converted into the packets which are ready for the transmission. So this is the block diagram of an IP television, which consists of a microphone converts an audio signal into the electrical signal, after which it is converted, digitized and compression, then a time stamping is done. Provided further with the IP addresses. Similar way, it is given to the packet switching network, where it's a computer network consists of the different routers. The IP packet is transmitted to the desired location through this router section, and at the receiver, IP receiver section will receive this packet. Depending upon the time sequence which is stamped at the transmitter side, it is decoded and given to the audio converter section. So audio converter section, what it does is it converts the digital signal into the decompressed signal and further to the electrical signal, which is given to the loudspeaker for converting electrical to sound signal. So this is what and travel of an audio signal from a mic through a internet protocol network to the receiver side. Audio signal processing includes the audio signal filtering, pre-emphasis and de-emphasis, as what we have studied in case of frequency demodulation. And as we are going with the pre-emphasis and de-emphasis, it is important to go with the compacting and expanding audio. Noise reduction is one of the important part, then audio digitization and then audio compression. We'll proceed further with, let us try to understand a signal which is converted by mic, which is applied to a filter whose cutoff frequency is around 300 to 3300 Hertz, which is exactly the baseband signal frequency band. After passing it through the filter, it is given to the pre-emphasis section. Pre-emphasis and de-emphasis is nothing but the lower frequencies are expanded and the higher frequencies are compressed, and vice versa is done in case of the de-emphasis signal. You are just observing here the gain versus input frequency characteristics, and you will find that as frequency increases, the gain is increasing, and in case of de-emphasis, exactly the opposite case, means as frequency is increasing, the gain is decreasing. So this is exactly taken care of to reduce the low frequency noise which comes in the audio transmission especially. So proceed further with audio compression. In case of audio compression, it is encoded in such a way that smaller amount of information or to reduce the bandwidth. The compression is basically converted into two types, which is called as a lossy compression and lossless compression. In case of lossy compression, the signal is lost, and in case of lossless compression, the signal can be recovered as it is. Few coding processes which includes to perform this task is waveform coding, perceptual coding, and voice coding. Waveform coding consists of A to D converter and data compression circuitry. waveform codes are capable of compression and decompression of signal, like it's a voice signal, music signal, or a modem signal. So modem signal is nothing but signal from the modem, which is modulation and demodulation process. Perceptual coding, it converts information into a format that matches the human senses. Human senses are, it can be visual senses or it can be audible senses. So this coding uses frequency masking and temporal masking. Temporal masking is a process of blocking, removing, or ignoring specific component of an audio signal that occurs in a specific time frequency or time sequence. In figure, you will observe that a particular loud signal or a multiple frequency signal or a small changes of signal, a particular signal can be ignored or can be blocked or can be removed by using this temporal masking. This gives you idea about a TCP IP multimedia protocol stack, which consists of two different models which already you had studied in the computer network. It consists of an OSI model, which consists of the 7 different layers starting from physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. As compared to the OSI model, that is open source internet protocol model, TCP IP model consists of 4 layers, started with the network interface layer, then internet layer, host to host transport layer, and application layer. So TCP IP protocol should consist of Telnet, FTP, SMTP, DNS, RTP, and SNMP, or it is also called as TCP UDP. TCP/IP model is of a 4-layer structure. Application layer refers to standard networks like HTTP, FTP, and Telnet. Transport layer manages transfer of data using connection oriented, that is TCP, and connectionless, that is UDP transfer protocols. Internet layer manages addressing of the packets and delivery of the packets between the network. And the network interface layer delivers data via physical link. So the network layer function is to establish a physical link. Internet layer function is to direct it towards the proper address. Transport layer is managing the transfer of the data, and application layer refers to standard network services.